Hey everyone. So we've already learnt about acids and bases, how they're a group of chemicals that are either sour or bitter. So we're focusing now on how scientists actually measure how strong acids and bases are. And the way they do it is with this scale here called the pH scale. So the pH scale is a measure of how acidic or basic a chemical is. Used to measure how acidic or basic a chemical is. Alright, so you can see here the pH scale, it ranges from 0 at the lowest up to 14, and right in the middle we have neutral. So any chemical with a pH 7, pH is the unit, but we always write it at the start, is just neutral. So it's neither an acid nor a base. And the most common neutral chemical is water. You can also see here that anything with a pH less than 7 is acidic. So that's where all the acids are found. And anything with a pH between 7 and 14 is basic. You might also hear the word alkaline. Alkaline just means it's a basic chemical that can dissolve in water. So it's soluble. Basic's the more chemically accurate term. Alright, so let's have a look. Where do some common chemicals fit on the pH scale? Well, coffee, anyone who's a coffee drinker, that's about pH 5. So coffee sits about here. It's only a mild acid. But the acid in our stomach is right down here at pH 2. Stomach acid. And being so acidic in our stomach helps us to break down our foods, as well as all the enzymes too. Okay, if we're looking at basic chemicals, remember basic chemicals are often cleaning products, and soap is a common one. Soap's about pH 9. And then if we're looking at really strong bases that are really corrosive, bleach would be one that's commonly found in your house, and that's about pH 13. Toxic and corrosive. Alright, so that's the pH scale. But there's another way of looking at the pH scale, and that's using all these colours. So the reason that acids and bases often are represented by colours is because of chemicals called indicators. Indicators. And indicators are a coloured chemical where if you put a few drops of indicator into another chemical, the indicator will change colour and tell you what pH that chemical is. So they're chemicals that change colour depending on the pH. So there's lots and lots of different indicators, but the best one is called universal indicator. And universal indicator is so good because it actually changes between all these colours that you can see in the diagram. Most other indicators only change between two colours, so they can really only tell you if it's an acid or a base. It can't tell you the actual pH. So universal indicator, it's the most accurate one. Right, so if you got a bottle of universal indicator and you put a few drops of it into some vinegar, Where's vinegar on our scale? Here. If you put a few drops of indicator in vinegar, well then that solution is going to turn this colour orange. And then straight away that lets you know, okay, this vinegar must be pH 3. And then if you had some baking soda from the kitchen and you dissolve it in some water, put a few drops of indicator in, well then that solution is going to turn this blue colour. And then if you've got this chart handy, and normally it's printed on the bottle of indicator, it's going to turn blue, and then you'll match it to the chart and see that it's pH 9. So with one chemical you can find out the pH of any other chemical. And here's an example. So someone's got, what do we have, 7 different solutions here, and they've put a few drops of indicator into each one, and you can see that they're all a different pH. We've got this one is pH 0, pH 1, this one's about 3, this one's neutral, this one's about pH 8, 10, and that one's about 12.5. Alright, so we'll be practicing using indicators, and your cat is actually going to involve making your own indicator too, to test the pH of different materials. Alright, so that's the pH scale.